Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Daniel bin Roslan. Today I will present introduction about experimental investigation on the performance of residential air conditioning system using water condensate of subcooling. Okay, it is well known that air conditioning system consume the biggest energy in buildings. In hot countries, residential sector consume about 60% for energy of air conditioning system. To reduce the power consumption of the aircon, several methods has been investigated by researchers. First, using inverter to regulate the compressor speed. Second, using injector as an expansion device. Third, inserting nanoparticle in the con- compressor lubricant. And lastly, using condensate water. Okay, this is the result by researcher. First, 7 et al. Second, second researcher is Tissot et al. And the last researcher is Ibrahim et al. Okay, that's all for me. Thank you.
Hi, Assalamualaikum. My name is Ahmad Irfan from Group Cassio. Next, I would like to present air conditioner drawing and explanation. Okay, when system is on, the compressor will compress the gas coolant. The compressed gas coolant will flow to the condenser using a discharge line. The condenser will get rid of heat using a fan, and the heat will go out to the surrounding. In the condenser, it has a high liquid pressure, and the high liquid pressure will flow to the metering device. The metering device will drop the pressure from high liquid pressure to low liquid pressure, and the low liquid pressure will flow to the evaporator. The evaporator will change the low liquid pressure to low gas pressure using evaporate, and frost will occur. When frost occurs, it will decrease the air temperature in the surrounding. After that, the low gas pressure from evaporator will come back to the compressor, and the flow will be repeated until the system off. So that's how the process of the air conditioner happens. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhan Irfan bin Suharuddin. Next, I'll be presenting method of performance analysis. So there are two tests that we carry out in this experiment, which is without normal condensate water in normal condition, and the next one is using heat exchanger to lower discharge compressor. So the both are ways to generate subcooling. The method to investigate the effect of used condensate of the system. There are 5 parameters and 5 instruments to measure those parameters are needed. So the first one is temperature and be measured by a thermometer. The second one is pressure and be measured by be measured by pressure gauge. The third one is air velocity and measured by manometer. The fourth one is electric current and measured by ammeter. The last one is voltage measured by voltmeter. So this is the table accuracy of measuring instrument that we measured 20 minutes for 3 seconds, 3 hours. Sorry. So the last slide is the schematic diagram of a split type air conditioner with condensate water to lower the discharge temperature. So the diagram shows the flow of the air conditioner system. So by use the condensate will reduce the power consumption and increase the cooling capacity. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Yunus. I am from section 3. Lastly, as for this topic, I would like to discuss about the suggestion on system improvement of the destination air conditioning system. So, there are a few methods to improve the subcooling in residential air conditioning. First of all, we must always maintain and improvise the charge of refrigerant charge, because when there is not enough charge in the refrigerant, it produces an insufficient amount of subcooling. This limits the amount of heat from the refrigerant can be absorbed. When in extreme cases, insufficient subcooling may even lead to the refrigerant converting back to its gaseous form before it reaches to the evaporator coil. That's why this is a very important method to always recheck, so that there won't be any insufficient amount of subcooling. So another way of improvising the subsystem is that even by improvising the charge of refrigerant, it must always be remembered that this must just be at the right amount, because if it exceeds the limit, the excessive amount of refrigerant will boost subcooling into a very problematic level. And when at this level, the refrigerant will become very cold until the refrigerant itself cannot turn to the gas inside of the evaporator coil. As this liquid refrigerant flows into the compressor, it leads to a very dangerously high pressure levels. Thus, the liquids, unlike gases, can never be compressed. For this reason, no liquid refrigerant should ever enter your compressor. So, these are a few methods to improvise the system on residential air conditioning. Thank you. Have a nice day.
And hi everyone. Now, Assalamualaikum and hi everyone. Now I want to present about the performance calculation of the system. Before that, we need to know about the essential. There are input power, power consumption, cooling capacity, and coefficient of performance. At the right side, it is the equation for each of these. Next is input power reduction, cooling capacity, and COP improvement. And the right side, as I said before, it is the equation for each of these. Now is discharge temperature. Discharge temperature difference is not constant. As we can see in the graph, and the average is 7.6 degrees Celsius. Next is the input power. Input power decreased due to discharge temperature. Input power with condensate always lower than without condensate. The red one is without condensate, and the blue one is with condensate. Input power difference is constant. It's about 48 watt. Input power reduction is 5.9%. This is the graph for temperature of the condenser outlet. Temperature of the condenser outlet decreased due to discharge temperature decrease. Temperature difference are not constant, as we can see in the graph. The average of temperature is 2.7 degrees Celsius. Now we look at cooling capacity. Cooling capacities with condensate water are always higher than that of without condensate water. Condensate is relatively constant. It's average about 300 watts, and the with condensate its improvement is 11.2%. Last one is coefficient of performance. As we can see in the graph, the decrease in input power and the increase in cooling capacity lead to increase the COP. COP with condensate water always higher than without condensate water. As we can see in the graph, the blue one is higher than the red one. COP difference is relatively constant, and its average is 0.6. The COP improvement is about 16.4%.